This is a preview of my recent Chase and Explain episode that just released over at stormchasercoaching.com. If you'd like to see the full episode, click the link in the description box below to sign up for our Chaser Academy. Hey everybody, Trey here, getting ready for our first chase of the season. Sunday, March 2nd. The SPC has just upgraded the risk to a slight risk, level 2 out of 5 here in the yellow shading, basically the eastern Texas Panhandle into western and southwest Oklahoma. And they've actually upgraded the tornado risk to a 5%. This has been a setup we've been watching for a couple days now. It initially didn't look all that great. Several days ago, about 4 or 5 days out, it looked really good. Models kind of backtracked. And now the last day or so, it's really kind of snuck back up on us and it's really trended upward. So the setup is looking pretty good for tomorrow, and so I think this is going to be a good opportunity for us to do a little chase and explain video here. So I'm going to walk you through what's going on in my head right now, what I'm looking at with this tornado risk tomorrow across the southeast Texas Panhandle into western Oklahoma. Also risk for hail as well. So pretty concentrated risk right in those few counties on either side of the Oklahoma-Texas border there in southwest Oklahoma and the eastern Texas Panhandle. Just going to give you a quick look here at what I'm thinking. This is the NAM model from this evening, 0Z. I'm recording this just after midnight, now the day of our event, and haven't really looked at much leading up until now because it's kind of really snuck back into the forecast. I wasn't paying too much attention a few days ago. Models had really backed off, and now we've seen a big uptrend over the last day or so. The overall pattern's pretty simple. It looks to be a pretty notable cold core type event. I've got the 500 millibar flow and the height contours here, along with the color fill, which is temperatures. And the gray temperatures you see there, basically right in here with the center, right at the center of that closed trough, those are indicative of minus 24, minus 25 degrees Celsius temperatures aloft at 500 millibars. That is really, really cold air aloft. And so what that's going to do is that's going to start overspreading our area of interest there in the eastern Texas Panhandle and western Oklahoma by tomorrow afternoon. As that cold air comes in, that's going to destabilize the atmosphere pretty efficiently. It's not going to take much. We are expecting some morning storms tomorrow, morning rain showers, elevated storms, but those are going to move out really quickly. And the cold air and surface heating behind that first round of storms is really going to help us get destabilization pretty quickly. With a classic cold core type event, again, cold core comes from, we have that cold air right at the center of this closed 500 millibar low. We go down to the surface, and we're also going to see a surface low develop somewhere in eastern New Mexico and move into the Texas Panhandle tomorrow. You see it's kind of a broad low. You see the kind of closed contours there going up all the way into eastern Colorado down into the Texas Panhandle. Looks like a little bit of a low center right in there, southern Texas Panhandle. We have our 500 millibar low center and our surface low center in very close proximity to one another, and that is going to allow right ahead of that surface low for there to be a somewhat small area, those just few counties on the west side of the Oklahoma-Texas border there in the southeast Texas Panhandle and in southwest Oklahoma, where we're going to see adequate destabilization and right ahead of that surface low for a potential tornadic supercell risk. Moisture is going to be on the meager side. We have really not seen a lot of robust moisture at this point, but you see by tomorrow, where you get right in that corridor, just out ahead where that moisture tongue arcs back in. Dew points have really risen in the past few model runs as well. A couple days ago, we were looking at mid 40s dew points, temperatures getting up into the mid 60s, mid to upper 60s, leading to a really not all that robust of a threat. But now you can see there are 50 to 55 degree dew points or so right there in southwest Oklahoma. That's pretty robust moisture, and what's going to help that along is we're going to see that those morning storms kind of moisten the atmosphere a little bit to help things out. Take a quick sounding right there, Oklahoma-Texas border, kind of near the Hollis, Oklahoma area, and this is going to show you a classic profile for cold core tornadic supercells. This is going to be valid at 3 p.m. tomorrow on Sunday, and you see our instability profile is kind of short, but it's pretty fat there. Lots of instability in the lowest few kilometers of the atmosphere. 0 to 3 kilometer cape, right around 100 joules per kilogram. So we have plenty of instability, even though the value might not be all that high, about 800 joules per kilogram mixed layer cape. It's really all of that crunched into the lowest few kilometers of the atmosphere. So that's going to lead to really robust low-level updrafts, going to help really tilt and stretch that vorticity from the surface low into the vertical to aid in tornadogenesis in these supercells. We also do have a little bit of low-level shear in play, which is unusual for a true cold core type event. We do see those kind of looping hodographs there in the low levels. Low-level shear pretty strong, upwards of about 240 effective storm relative helicity there. So overall, this is a very classic, really upper echelon cold core type profile. So we're watching again that area right out ahead of the surface low, right where that moisture tongue arcs back into the low, right there in kind of the southeast Texas Panhandle and western to southwest Oklahoma. Right at that apex of the arc right there is where I'm initially targeting right now. It's going to be a wake up and see kind of day. Tomorrow's really hone in where we need to be exactly, but things are looking good for a nice cold core type event here. So these cold core type events can be very efficient tornado producers. Definitely a chase day here coming from Norman, going out a couple hours west tomorrow to see what happens. So we'll be back in the morning. I'm going to wake up early, look over the data and see how things look, and that'll really help us pinpoint where exactly we need to go. With these cold core setups, it's fairly easy. Get right out in front of the surface low, right along the warm front boundary, right at the apex of that moisture tongue, and that's going to be your spot. Not a very wide area of interest here, but it's very confined right ahead of the surface low, right along those boundaries. So the data in the morning is going to tell us where we need to be much more specifically than just this model run. So I'll be back in the morning and we'll refine our target then. Hey guys, just after 10 a.m. here on Sunday, March 2nd, and I'm getting ready to leave on the chase, and just want to give you a quick rundown of what I am seeing this morning. This is a setup where you really don't need to look at much of the model data, especially the cams. In these cold core setups, the target's usually pretty self-explanatory. Again, it's right ahead of the surface low, right where at the arc of that moisture. So let's go ahead and show you what I'm looking at this morning. Here's this morning's SPC outlook. They've expanded the slight risk in yellow from what we saw last night to include a little bit more of the eastern Texas Panhandle into western Oklahoma. Here's the tornado risk as well. The tornado risk remains pretty confined, at least the greatest risk there in the 5% Elk City, Altus, just those few counties on either side of the Texas-Oklahoma border in the Texas Panhandle into southwest Oklahoma. Pretty confined tornado risk today. Hail risk has been expanded from yesterday. The storms will have a chance to produce large hail, but that tornado threat pretty confined. And there's a reason for that. It looks like all the ingredients are converging right on this area, especially where the 5% is. It looks to be the initial target. So I like to start off with the mesoanalysis data. I've zoomed into the Southern Plains sector here, and here's our big trough, big old closed low with a nice strong jet streak associated with it. This is going to slide off to the east go into the next several hours, and that's going to provide that really cold air aloft. These red contours here, these dashed red contours showing minus 21, minus 22. Those are the temperatures in degrees Celsius aloft. Minus 22 degrees Celsius is very cold air aloft. We may even see some colder air than that work its way in over the next few hours. That cold air mass is going to overspread this region of the western Texas Panhandle, or the western Oklahoma, eastern Texas Panhandle, and that's going to allow for some really rapid destabilization. You see this band of showers that's developing right now. That's going to be our early round of storms. The models were showing this. It's pretty common in these cold core type setups to get an early band of storms. But as this cold air moves in behind this early band, it's going to really rapidly destabilize the atmosphere. And so it's not going to be much time that we need to destabilize after this early round. Things should get going pretty soon after that round passes through. Probably sometime by mid-afternoon, we should start to see development behind the early round of storms. As this moves in, that is going to also coincide with a surface low. Here's our current surface data. You see the surface low kind of developing out there in eastern New Mexico into West Texas. It's going to kind of broaden out a little bit as we go into the day today, but we're going to have a nice little arc of moisture feeding up into the surface low somewhere up there in the West Texas, Northwest Texas, western Oklahoma, somewhere in that region. Here's our current surface observations, and you can see the kind of counterclockwise flow right around there, the Texas-New Mexico border region. Dew points are definitely on the low side. You see up here in our region of interest, Childress there, 53 over 32, 39 degree dew point there at Frederick. Very limited moisture at this point. We do have mid 40s just to the south, and actually what is unique about this setup is that initial band of showers that we talked about on radar back here, that may actually help to increase dew points in this setup, which is somewhat unusual, but that may actually help us get a little bit more of a moist low-level air mass that we need to really sustain any type of supercell activity here. Usually on a severe weather day, when you see low 30s dew points in your target area by mid to late morning on your chase day of interest, that's not a good sign at all. But we are going to see this moisture rapidly advect northward as this surface low starts to deepen out here across eastern New Mexico and West Texas. So these mid to upper 40s dew points going to rapidly make their way northward into the eastern Texas Panhandle and western Oklahoma. And if we can get some help from that morning round of storms, those dew points should be hovering right around 50 or so, maybe even into the low 50s at best, which if we get that, temperatures warm up into the low to mid 60s, it's going to give us a nice little air mass in the low levels to support some supercell activity. Again, right ahead of that surface low, going to build off to the east a little bit, and that moisture is going to kind of feed up in a little bit of a tongue right there out ahead of that low. Just real quick look at the HREF. This is our ensemble system that takes into account all of our different convection allowing models into one ensemble. It basically takes a mean of all the ensemble or all the individual cam output, and it's a much better tool to use than individual convection allowing models. I just wanted to show you real quick the movement of this trough going to move off pretty quickly to the east today. This is going to be valid at 21Z, so 3 p.m. today, that core of the closed low right there over the Texas Panhandle. So all that cold air going to start to overspread that region of the eastern Texas Panhandle into western Oklahoma. Right ahead of that is going to be where we want to be. Our surface low also going to be moving into that region as well, and we'll have that nice arc of moisture feeding up into that surface low. So you see our best dew points here. This is this morning 12Z as these models were initialized. Very limited moisture up to the north. It remains that way until we get into early afternoon. We start to see that low expand a little bit of a secondary center maybe there in the Texas Panhandle. And right out ahead of that, you see a spot of the darker green. That indicates 50 plus dew points right in there. So all the models are kind of on board with that little spot right in there, far southeast Texas Panhandle into southwest Oklahoma as being the area of best moisture. And that's where storms are going to have the most juice, if you will, to fires. It looks to me like that's going to be the spot. We're going to have to monitor the surface obs going through the day to see if those dew points actually do make their way up into the kind of 50-degree range. If we can get there, then we'll have a good chance for robust storms. If we stay in the mid 40s or so, that's going to be problematic, and we may only see a large hail threat and maybe some damaging winds with those storms. Tornado threat would be limited, but if we can get those dew points up into the 50s with surface temperatures in the 60s, we should be in good shape. But all signs are pointing to that area right there in southwest Oklahoma to the southeast Texas Panhandle as being our area of interest. Real quick, this is our ensemble of updraft helicity streaks. Not going to be much to show for with this because with these low top supercells as they're going to be today, the models have a hard time trying to depict real robust rotation within these storms. But you can see we do have a little bit of a bullseye there right in where that slight risk is, right where the 5% is today. That is going to be where I think the target is going to end up being. So for now, going to start heading that way here shortly. I'm going to go down I-44 here from Norman, and we will make our way down there, probably setting up somewhere near the Hollis, Oklahoma area, maybe near Altus. We might stop in Altus and kind of reevaluate from there. It's about 2.5 to 3 hours down there, so we're going to get a head start on that here soon, pack up the cameras, and hit the road. So we're heading down I-44 now, just before noon, and the visible satellite imagery is looking pretty textbook here for one of these cold core events. You see the band of storms that has formed there moving into the eastern Texas Panhandle, northwest Texas into western Oklahoma at this time, with maybe some bubbly cumulus starting to go, but we're still a ways off from initiation as the trough is still back in here in the mid and upper levels, so we still have some time. Our target right now is going to be Hollis, Oklahoma, very far southwest corner of Oklahoma. We're going to probably sit there. Storms might initiate just on the Texas side of the Texas-Oklahoma border, probably right around 2 p.m. or so, and we should be arriving right at that time. So definitely optimistic for how things look, and we're going to continue chugging on. We'll update you guys in about an hour or two. All right, so it's about 12:15, and we have a new update here. You'll notice that storms are actually already starting to fire all the way back here, just to the east of the Lubbock area. That is a little bit concerning at this point. That's much earlier than we expected, and if those continue to develop there, then the timing of this whole setup might be a little bit off. If we switch to the Texas Mesonet, the West Texas Mesonet from Texas Tech University, the storms are going up just out in here. This is the town of Spur right there, just out ahead of these storms. Spur is showing a temperature of 73 and a dew point that's in the 40s. The station plot shows 73 over 42. So that's very dry air that those are forming in. So if this is going to be the main show back out here in the drier air mass, then we may be in a little bit of trouble here. Hopefully we can get some more storms to develop a little bit farther northeast in the actual moisture axis. We've seen a little bit of improvement since the morning in the dew points up here. As this band has gone through, the dew points are now up into the 40s. Expecting a little bit more increase in the dew points later this afternoon, is probably closer to 50, hopefully closer to 50. But if this is the main show, they're firing in the dry air, and usually that's not a good thing for these cold core setups. Usually the storms fire in the moisture axis and then kind of advect or get transported with the moisture axis as the surface low moves off to the east or northeast. So a little bit of a concern at this point. Going to keep monitoring Just about to get to the Lawton area, at which point we'll be heading west toward the Hollis area. Other than that, the target is still going to be Hollis for now. We will adjust as needed. So we're here in Altus, Oklahoma right now, getting gas. We're just gonna take a look at some things right now. We are in the middle of the little first band here. You can see kind of the cloudy skies behind me. So we're about to break into the sunshine in just a little bit. We're gonna just look at things, see where we need to adjust from here, and then we'll go from there. All right, so it's just after 1 p.m. here in Altus, and here's our current visible satellite imagery. You can see the arc of storms is developing right here, just in northwest Texas right there. Storm's starting to really blow up. They're going to be moving northeast into this area of better moisture. We've seen some real increases in the moisture after this initial band has gone through. It's actually raining here in Altus, as you can see on the windshield there. So we're right in the middle of this band, but it is moving off to the east pretty quickly. Here's the West Texas mesonet. It's a great site to use, just like the Oklahoma mesonet, to kind of fill in some of the gaps for some of the gaps in surface obs out here in northwest Texas. And you can see the dew points here. This is the dew point display. We are up to the low to mid 50s here, even some 55-degree dew points down here in northwest Texas. Childress there at 53. So the storms are moving up into this corridor, and we're not getting a nice arc now along that just to the west here. So those are going to move into the better moisture. Hollis is right in here, just right before you cross into the border. Cross into Texas. So we're probably going to head to Hollis. They're all just kind of streaming up this way. We'll have road options from there. Here are the storms we're watching. We are the blue bullseye right here in Altus, and these are the storms we're watching, kind of firing again in that arc just near the Paducah area, heading up toward Hollis and Childress. So we're probably just going to inch east a little bit out ahead of these storms. Nothing really too robust right now, as you can see on radar. They're still kind of percolating out there, but as they move into the better moisture here in far northwest Texas and southwest Oklahoma, they will be in a much better environment to start doing something interesting. Looks like we do have an MD, a mesoscale discussion out. That's the blue outline you see here. Let's see what they have to say. 40% chance of watch issuance. They say diurnal heating is underway across parts of the Texas South Plains and southeast Texas Panhandle in the wake of elevated convection. That's this stuff that's going on here that we're experiencing in Altus right now, this band out to the east. Convective initiation is underway near the dry line east and southeast of Lubbock, so those storms down there. Additional thunderstorm development is expected this afternoon as strong ascent overspreads the region. So as that trough comes in from the west that we talked about earlier, here is the trough. Location of the trough right there in the western Texas Panhandle right now. So as that continues to inch forward, we'll continue to get that cold air overspreading the region, further destabilization, and that's going to allow for storm robustness to increase. All right, back to our mesoscale discussion here. So they're expecting additional development here as we go into the next several hours. They say low-level moisture remains rather limited, but mid and upper 40s dew points and locally higher will be sufficient to support mixed layer Cape near 500 with continued heating and cold temperatures aloft. And we, again, are even seeing dew points in the 50s down here in northwest Texas. So would expect perhaps even a little bit higher than that for instability. Deep layer shear is more than sufficient for organized convection. However, given the strong forcing, an arc of convection with one or more small embedded supercells may develop with time, posing a risk of hail and localized strong to severe gusts. Some threat for a tornado may also evolve with time, especially with any supercells in the vicinity of the warm frontal zone, where locally higher dew points in the low 50s, which is where we were talking about in kind of that Childress vicinity, and a relatively favorable overlap of low-level instability and vorticity will reside. And we're seeing a lot of vorticity at this point. If we go back to our mesoanalysis data here, we go to our multi-parameter fields and vorticity in 3K. You see a lot of blue contours there. That is surface vorticity. So all of that is building in right near the surface low. We've got a nice little lobe of it up there into southwest Oklahoma. Expecting as we get continued heating and continued cold air advection aloft, we should get that vorticity and 3 Cape to overlap to get that real nice stretching of vorticity into the vertical by these updrafts. So the forecast seems on track. We're going to inch east, continue to inch west, toward Hollis, and go from there. We've got a decent road network out of there that will take us really any direction we need. We can just go into Texas if we need, down to the south of Wellington toward Childress, or we can go back to Duke and down south to the Quanah area if we need. It's a nice starting point. We're going to hit the road west here. We'll be breaking into the sunshine in just a second. That will give us a nice sense of the environment ahead of these storms. Driving through the town of Duke, Oklahoma right now, you can see we've kind of broken out into some clearer skies here. We've cleared that initial band of storms that has moved off to the east, and we're now in the warmer air here as we go through Duke. The plan now is that we're going to go to the town of Gould, which is just about 10 minutes west of here. That gives us a direct south option if we need it. The storms are coming right up this way, so we can shoot west, east, or south as needed from Gould, and we should be in a good position there to catch those storms coming up from the Childress area. Moving pretty fast, about 40 miles an hour to 45 miles an hour or so. So we're just going to wait up here. We have to be mindful of river crossings in scenarios like this because we're right on the Red River, so it can be difficult, not that many crossings, so we're going to have to be careful of that. Either stay on the Oklahoma side or pick a route that can get us from the Texas side back easily into Oklahoma. So that's the plan for now. We'll check back in as we stop in Gould. Looks like we have our first severe thunderstorm warning of the day. It's this northern storm out here near Childress. It's moving right up this way toward Hollis and Gould. We are the blue bullseye right up there. So we should be in Gould in about 5 minutes or so. Going to reassess there and then get in position as needed. This looks like our first possible attempt here of the day, with more storms down along the line starting to percolate. So this one also has a tornado possible tag on it, so we're going to get to Gould. No north road out of Gould. We'll have to go to Hollis or back to Duke, but we have some good options from here, and we have some time here before this gets up this way. So gonna get to Gould and then reassess. All right, we've just decided to go to Hollis. We're passing through Gould right now. Looks like this storm is heading directly toward Hollis. That should give us a good view. The other option would be to cross into Texas and get on the highway that goes down to Childress, but that would be a little bit difficult as there's really no roads southwest of here in the far northwest portion of Texas other than that. As far as north-south roads go. So the best bet I think for us is to just go to Hollis. We're not going to be able to go south from Hollis. If we need to go south, we'll come back here to Gould. But it looks like the track that this storm is taking is going to take it just west of or in Hollis. So that should give us a pretty good view as it comes up from the southwest. All right, just after 2 p.m. now, and we are watching this storm that is just to our south. We're on the south side of Hollis right now. The Red River is just right over here. You can see the precipitation core with this supercell. Very high reflectivities on radar. Let me show you the radar. So we are the blue bullseye right there just south of Hollis, and this is the storm we're watching. Very, very beefy on radar at the moment. Very intense hail core. Does have a little bit of rotation potentially right now, so we're going to watch this one closely. And we have some options. We actually have a river crossing that's close by that we found that we may be able to take to get closer to this, but right now, don't see anything super imminent at the moment. With these cold core setups, you do have to be careful as these can produce pretty quickly. But right now, I'm just going to sit here south of Hollis and watch this storm. And you see a little bit of a lower region right there, just to the right of the tree, just right in there. So we're going to watch that closely and see what this does over the next few minutes, and we'll readjust as necessary. Taking a look at infrared satellite right now. Here's that initial band, and here are our storms that we're watching. This north one is the one that we are watching most closely right now, that looks most robust. You can see it has the broadest region of coldest cloud tops. Those green colors are indicative of the coldest cloud tops right now. We are watching the storms to the south. They do appear to be getting a little bit more robust, but this north one right now appears to be the most robust, the broadest region of tallest cloud tops or coldest cloud tops. And usually in these cold core setups, you want to be tucked right up underneath the surface low, right at the apex of the arc. You can see the arc of supercells right there. Usually you want to be right on the apex of that. We are watching these down here. They're getting a nice little shape to them, but overall this north storm looks to be the most potent at the moment with the best signs of rotation. So we're going to continue to watch that. It's about to cross that highway east of Childress and go up into kind of a road-free area, but we do have a road that we can take if we need it that might get us across the river, get us a little closer. But for now, just going to sit here south of Hollis and watch this thing percolate. Here is the Oklahoma mesonet right now, just about 2:11 p.m. Still watching the storm south of Hollis. You can see it here off in the distance, really thick precipitation core with a somewhat of a lower region off there to the right near that tree. Here is the current surface observation map, and you can see that we have really moistened here. Hollis, Oklahoma, where we are now, 62 over 54, 62 over 57 down by Frederick. Very moist air mass at this time, which very different story from this morning. And my concerns are really have been eased over the last hour or so as we've had that first band come through and the dew points have risen. These storms are moving into a pretty good air mass, a little cool as far as surface temperatures go, but you don't really need a lot of surface heating in these setups. A lot of times these cold core setups will happen with temperatures in the 50s or 60s. So not too worrisome. Still liking where we are. These storms are going to be tracking into this really juicy environment here over the next few minutes. So we're in a good position, and we have road options as necessary. 2:15 p.m. and we're watching this merger. Notice this little shower that's going up right into our storm of interest. We'll see how this responds in the next few minutes. The merger is underway right now. Still see that lowered area just to the left from our view of the precipitation core. Has some pretty large hail in it, it appears. So very interesting merger going on. We'll see if anything happens with the storm's intensity at this point, but it's coming right up toward us. We'll have a great visual if it does anything. So I'm interested to see what this merger does. Here's a view of the southern storm that we're watching by Kroll. And this is a really good example of how you have to really be careful when you're looking at velocity signatures to make sure they're accurate. This is clearly an example of side lobe contamination. The nice supercell shape there on reflectivity, and you see a nice strong rotational signature there. But if we circle it and see where that exactly is, you'll notice that it's on the forward flank of this storm. So it's not even close to where it should be, which is right in here at the tip of the hook echo. So always be careful in these situations. I took my first glance at that storm and saw this rotational signature. I was a little worried that we were out of position, but it does appear to be side lobe contamination, which happens when the radar beam picks up more energy in its side lobes. You can find out more about this in the Radar for Storm Chasing course. But it has more energy in its side lobes rather than the main lobe of energy coming off from the beam. And so that allows for a false rotational signature that shows up in the wrong spot. We're still watching this storm up here to the north. It's looking a little bit messy at the moment. Has to go through this merger and maybe it'll start to work itself out, but we're still watching that lowered area. Doesn't look quite as good as it did a couple minutes ago, but we are still watching this and we'll see what happens. Process of completing, so we'll see if something starts to happen here, but definitely liking the look of this storm right now. It's 2:25 p.m. now, and not loving the convective evolution with this northern storm. You can see after the merger, it kind of went through a couple other mergers, and it's now just looking like a little bit of a linear segment, which is not great. This storm to the south has a 3-body scatter spike on it. You see a little spike there indicating large hail. It's all by itself, is going to go through some little mergers, it looks like, here over the next couple minutes. So I think what we're going to do is go back to the east, maybe toward Gould or even Duke. We have south roads from there, from each of those places that we can take, but we just want to get ahead of this, get a better visual back into this guy in case it does something, or we can get in position for this one here down by Kroll and see if it does something as it crosses the Red River. So it's 2:34 now, and we're traveling east back toward Gould and East Duke. We're going to try to see what we're going to do here. Looks like this storm that we were watching is now just a complete line, so that might be out of the question. We're still monitoring it. Looks like that lowered area we were watching before is more of a shelf cloud feature, more of an outflow feature, so not in love with that. We can see it off to the south. It doesn't look all that great, but we're going to keep it in play just in case. We're probably going to go back to Duke, then down toward El Dorado and Olustee. There's some roads that get us east, just close to the river, to the south of Altus, to get this southern storm by Kroll that's coming up. You'll notice here that this sky, very gray sky now, probably a lot of anvil overspread, and we didn't get a lot of pure heating up here. So the temperatures are a little bit cooler. Down to the south, it's a little bit warmer, 65-degree temperature down there in the vicinity of Kroll. So I wonder here in this part of southwest Oklahoma if we didn't quite have enough time to destabilize. Even though in these cold core setups it doesn't take much, perhaps it wasn't quite enough up here. It's a little too cool, and storms just are struggling to remain surface-based or inflow dominant. But we're going to keep it in play. It still looks somewhat robust in the line behind us. Could be some supercellular elements in there, and then we're watching very closely this southern storm that could be of interest here in the next hour or so. All right, 2:51 p.m. now, and a little bit of an audible we've pulled. We've stopped in East Duke, It looks like this southern storm from our original complex of storms has kind of broken off into its own supercell, showing some signs maybe of some rotation, nothing real intense at this point. Supercell to the south also coming up this way. I usually don't like hedging my bets on two different storms at this point in the chase, because that's how you can get burned, by just kind of getting stuck in the middle between the two. But these storms are in such close proximity, and we have some roads that can get us to either. I'm okay doing that. Nothing really looks super imminent at this point. We're watching both of these storms. This storm, I think, has perhaps the best short-term potential. This one down here all by itself might struggle a little bit because it needs some more storm interactions around it to help balance out that inflow and outflow. Again, in cold core setups, you want to be a little bit farther up the arc of supercells. And it looks like this one might have the best short-term potential. So we're going to keep it here near Duke and see what happens. Not super confident at this point, given the convective evolution, but it's moving into a decent air mass. Both of these storms are, so we're just going to wait and see what it does, and we have roads to intercept as needed on both of these storms. All right, so our storm here to the west is wrapping up pretty significantly. Has much more rotation on it now. Unfortunately, it looks like the storm mode is going to get a little messy here. That storm to the south is kind of fizzled and a lot more convection going up around it, so this might be our only shot. We don't have any north roads from Gould, so we're just going to go back to the west, see if we can get somewhat close to this area of rotation, and try to see if it does something right there, as that might be the last chance for anything super visible. All right, 3:03 p.m. rotation is increasing significantly with this storm. Again, the storm mode is going to get a little messy. We're in some of those showers that are forming out ahead, but we should be pulling out of those here in a second, and we should have a visual back down into this thing. We're about 15 miles, and there's the tornado warning. Tornado warning just got issued for this storm. Moving up just on the east side of Gould. We're about 5 to 6 miles or so from where we need to be. Hopefully this thing will start to really get its act together as it comes toward the road toward us, but looks like it's going to slide just east of Gould, perhaps, which is a good sign. We should get a visual here in just a second as we pop out of the rain. Tornado looks like it might be pretty rain-wrapped. The rotation's really increasing. Wouldn't be surprised if there's something back in there. So we're just going to kind of inch up on this. We're on a main highway, which is good. Just let it come up to us as it sneaks by Gould. And we'll see if we can see something back in the notch here. We've got a visual now. Here's our area of interest right there. We believe it's in this rightmost area of precipitation, just right of that region of clearing right in the center of your screen. 3:08 p.m. Here's our current situation. Storm is heading right up toward Gould. You see the strong rotational signature there. Just tighter about one scan ago, so very well could be something in there. Here's our visual of it. You see it's very, very rain-wrapped in there, so we can't really see anything, make anything out right now. We're just going to inch up to it. We have this main road here. Just going to inch up to it and see if we can see anything. We've got really good service. Got a visual here just to its northeast, so that's why we're able to safely do this maneuver. If we didn't have visibility or service, I would definitely not be doing this maneuver, or a main road for that matter. So we're just going to go slowly and see if we can see anything as it moves up toward Gould. All right, we're just a couple miles east of Gould right now. Storm is coming basically right at us. Still can't see much in the precipitation core there. It's definitely a high precipitation supercell. It has some good structure on it. You see the striations there, kind of a little bit of a shelf cloud on the leading edge. Any circulation probably tucked back in this rain here. Can't really see much, but it's going to cross very close to us here. We've got this main east-west highway that you see here that we can use as an escape route, have an easy escape route back the way we came from the east. But this is a beautiful supercell, and we're just going to watch it here. We flipped around. We're ready to move if we need to make a quick escape and go back east, but we're in a good position right now and just going to continue to monitor. All right, 3:13 p.m. rotation has broadened out a little bit. We're still in a good position, same spot just east of Gould. We're about looks like we're about 3 miles east of town. This thing's going to skirt right by us, and we're watching this straight on. Again, still have the escape route if we need it. Can't really see much in the rain there, but it's definitely still some pretty significant rotation in there. Doesn't look tornadic at this time. Still kind of a broad rotation, but it's going to cross right in front of us, so we'll be able to see anything if it does anything as it crosses the road. is at my back. It's blowing from east to west, so that means we're in a good spot. The wind is blowing at the circulation, so we know the circulation's in front of us relative to where I'm facing now, toward the east. Just a real beautiful, beautiful high precipitation storm. All right, just after 3:30 p.m., we are just south of Mangum right now, and everything's pretty much evolved into a line at this point. No real supercell structures remain in this line. Rotation has definitely decreased on our north end storm there. We caught it right as it was ramping up, so definitely happy with the execution there, but looks like the chase is just about over. Mostly just a structure show at this point. Still some nice high precipitation structure on this thing. Nice little shelf cloud there extending quite a ways to the south, but overall we'll probably just watch this for a few more minutes, see what happens, and then call it a night. Something there.
Texas Roadhouse?
Yes, let's make sure there are no stupid prefrontal supercells that we need to worry about after dark. About 3:40 p.m. now, and clearly can see the shelf cloud structure on this. Some striations poking through. Really nice structure to end the day. But you can tell that it is mostly outflow dominant at this point. You can see the air kind of pushing out on the leading edge of the shelf cloud there, rather than actually rotating. Still have some inflow at our backs here. So the outflow is not surging well out ahead, but you can clearly see just kind of has that look like it's mostly done in its supercellular state and has moved on to more just of a line. So gonna spend a few more minutes here getting some shots, and then we will call it a day. All right, it's about 3:50 p.m. and we have called the chase. We are heading back toward Duke, and then we're going to head over toward Lawton to get some dinner. Pretty fun day, pretty good chase. Happy with the execution. Not much came out of this setup. Oftentimes that's the case in these early season setups, but happy with how we targeted and happy with how we executed, getting close to the only tornado-warned storm of the day, so can't be too upset about that. Now just driving next to this line here, some cool-looking skies on our way back to Lawton, but we'll reconvene once we get to Lawton and do a final wrap-up there. All right, so we made it back to Lawton safe and sound. Gonna grab some dinner now. All in all, a very successful chase. First chase of the season. It was nice to get the rust off. Didn't quite go as planned as far as storm mode goes. We'll recap that later once I get back and look at some data. But overall, very happy with how we executed today. Got on the only tornado-warned storm in the entire setup today, so can't complain at that. Got some great structure from that storm. So all in all, a really nice chase to start the season, and couldn't be happier with how today went. So it's a few days after the chase, and I've had some time to reflect on what went well, what didn't go so well, and overall pretty happy with the execution. We were on the only tornado warned storm of the day, despite the storms not really cooperating for us. So can't really complain about that. Storms just didn't do their part. Overall, really like our execution. We had a well thought out plan there, especially as that storm started to get a little bit high precipitation and a little bit more dicey, if you will. We had lots of escape routes and plenty of visibility. So happy with how we executed, especially as that storm got tornado warned and a little bit more high precipitation. The one inflection point to maybe work on for next time is the decision to stay north of the river. When things were first getting going, just south of Hollis, we were watching that wall cloud of the storms as they were just south of the river. Usually in cold core setups, you want to be on the initial updraft pretty early on, as they can start producing tornadoes pretty quickly because of that strong vorticity stretching and strong low-level instability. We maybe got a little bit lucky that the storms did not really produce. Maybe it would have been a better call to go south of the river. But overall, didn't really harm us at all. We still had visibility, and that area is just a little bit tricky to chase in because there just aren't that many roads down there between the Red River and that highway 287 near Childress. So overall, didn't hurt us, but definitely something to keep in mind for cold core chases in the future. The next question is why didn't the storms really cooperate? I think there were two main reasons for that. Number one is that storms fired pretty early. You could hear in the video as we were driving down there, storms went up just after noon, and that was much earlier than expected. So I think it didn't quite allow the atmosphere to destabilize. After we left Altus and the rain moved out, we did get into sunshine a little bit there for a few minutes, but it didn't last all that long. We got right back into the cloud cover, and temperatures were pretty chilly. We stepped outside, and it was pretty chilly. So I don't think storms quite were able to take advantage of a fully destabilized environment. So I think that was one reason. The second reason is usually in a cold core setup, you want that surface low to be really tight, well-defined out ahead of your 500 millibar closed low aloft. And in this case, it wasn't quite that way. The surface low was actually a little bit behind the 500 millibar low. We did have a decently tight surface low and a nice little arc of moisture up into the low, but it just wasn't quite the right configuration for a true cold core setup. So it wasn't quite as focused perhaps as it might have been with a nice tight surface low ahead of the 500 millibar cyclone. So that was one reason. I think that coupled with the lack of instability was the doing in for this setup. But again, overall, happy with how things went. It was a nice way to kind of kick off the season, and hopefully there'll be more good opportunities soon. So that's going to wrap things up for this first Chase and Explain video here on Storm Chaser Coaching. Hopefully you all found some useful tidbits from this video. It wasn't, again, quite the most fruitful setup, but hopefully it gave you some insight into my thought process about how to attack these cold core setups. We'll have a lot more of these Chase and Explain videos here on Storm Chaser Coaching going forward. Fingers crossed for some more fruitful setups for those videos. But for now, thank you all for being members, and we'll see you next time.